John's traveling to Portland at 100 kilometers an hour, and Dan follows John 15 minutes later and plans to catch up to John. So he's going to travel for 15 minutes less. John's going to travel for 15 minutes more. So if Dan travels at v kilometers an hour, and it takes him t hours to catch John. So the v kilometers an hour and t hours relates to to Dan. So we want to find the distance in terms of v and t for Dan and John. So for part A, the distance for Dan is going to be the velocity for Dan times the time for Dan, which was given at the beginning. For John, we have to travel, we know his rate of speed, and we know that he travels 15 minutes more. So the distance for John is going to be written this way. So velocity times time. So John, his velocity is known at 100 kilometers an hour. His time is unknown, but we know it is 15 minutes longer. Now we have to be careful with this because the velocity is in kilometers per hour, but the time is in minutes. So we have to convert that 15 minutes into hours. So I'm going to use 0.25 hours. There's my expression for the velocity for distance for John. So for part B, it says express t in terms of v and graph this relationship. So for B, we're going to express Dan's velocity, Dan's time as the distance divided by velocity. Okay, and in this case, the distances are the same for Dan and John because they're both traveling the same distance, so we're just going to keep that as d. And that expression comes from Dan. Now there's too many variables to graph here, so we're going to have to write one for John. So the time is equal to, time plus 25.25 is equal to the distance divided by the velocity for John, which is 100, and then we can solve for t. It's going to be distance over 100 minus 0.25. Okay, so there's the expression for time as a function of the distance in this case. Okay. Express t in terms of v, so that's the one we're looking for here. So for part C, it says how long would it take for Dan to catch John if Dan is traveling at 120 kilometers an hour. So we need to first of all come up with an equation because we're solving for something here. And the equality is the distance for Dan is going to be equal to the distance to John. That's because they're traveling to the same place. So I'm going to make the distances equal to each other. So distance for Dan is v times t. The distance for John is going to be 100 times t plus 0.25. The velocity for Dan is now given as 120, so I'm going to replace that with 120 kilometers per hour, and then we solve for t. So I get 120 t is equal to 100 t plus 25. So 20 t is equal to 25. So the time is going to be equal to 25 over 20, which is 1.25, and that's in hours. So the equation that we need to come up with is this one here, is based on this equality, and then we can use this equation to solve this problem.